Now this video is going to be on rates of change. Now we've seen how the derivative is used to determine slope, right? M equals y2 minus y1 over x2 minus x1. We've also seen how the derivative can be used to determine the rate of change of one variable with respect to another. Now, what do I mean here? Well, the rate of change, isn't that just what the slope is? Y2 minus y1 over x2 minus x1. Isn't y changing as x changes? Right? This is delta y over delta x, right? So we can see that this is just as one is changing with respect to the other. Now, we've got a lot of different applications that involve rate of change, ranging from things like population growth to production rates, water flow rates, and for this section, most importantly, would be velocity and acceleration. So, when we're talking about position, velocity, acceleration, all these kind of things, we're generally describing motion of an object moving in some kind of straight line. That's the most simple and basic way. We can change it up and start talking about things moving in a curve, but it gets a little more complicated. So before we jump into that, we've got to start with just basic motion along a straight line. Now in these problems, it's customary to use either a horizontal or a vertical line with a designated origin to kind of represent the line of motion. We did this a little bit in trig when you had to do vectors, right? If we had a vector that wasn't along the x-axis or along the y-axis, we would decompose it into its I and j components because it's easier to deal with. We're going to do the same thing here. We're really just talking about line of motion along the x-axis or along the y-axis or horizontally or vertically. And anytime we do this, excuse me, just like with our vectors, if we're moving in the positive right direction, that's a positive movement. If we're moving up, that's the positive y direction. So up and right are both positive directions, whereas down and left would be negative directions. So a function s that gives a position with respect to time is called a position function. And we're going to see this quite a bit. So we're going to call s the position function at a specific time, and we're going to use a formula to figure this stuff out, right? We're going to use the fact that rate equals distance times time, or divided by time, sorry. The distance is going to be from final minus initial. Time is going to be final time minus initial time. It's always, anytime we find a delta, anytime we find a change of something, it's always the final minus the initial. Or y2 minus y1 over x2 minus x1, right? The final y value minus the first y value, the final x value minus the initial x value. So this is what we're going to call the average velocity. Excuse me. Now, average velocity is really easy to find. You just take the total change in distance and divide by the total change in time. For example, say I'm going from Athens to Nashville. It's about 100 miles. And I tell you, I went from Athens to Nashville and it took me 2 hours. Well, what was my average velocity? Well, my change in distance was 100 miles. The time it took me was 2 hours. 100 divided by 2 would be 50 miles per hour. And that's the average velocity. Now, in terms of s, we can say that our average velocity will no longer be y2 minus y1, x2 minus x1. Our y would be s of t2 minus s of t1 over t2 minus t1, right? This is our final time minus our initial time, and the position function at the second time minus the position function at the first time. So s of t2 minus s of t1 over t2 minus t1. I've got all this wrote here. We don't need that yet. So we're going to use that piece of information, s of t2 minus s of t1 over t2 minus t1. So this is our s function for this problem. A billiard ball is dropped from 100 feet. The ball's height at time t is given by negative 16 t squared plus 100. Now in this case, s is measured in feet and t is measured in seconds, so we know our answer or our velocity should be in feet per second. And we want to find the average velocity over a couple of different intervals. The first interval we're looking at is from 1 to 2. So this is the time t1 is 1, t2 is 2. So from time 1 to time 2 in seconds. So really all we got to do is just plug these values in. So we're going to start with our final. So ST2. So that's going to give us negative 16 times T2 squared plus 100. So that's our S2 minus S1, which is negative 16 times 1 squared, which is just 1, plus 100. And all of this is going to be over T2 minus T1, or 2 minus 1. So negative 16 times 4 is negative 64, plus 100 is 36. Negative 16 plus 100 would be 84, and then minus 84. So minus 84 all over 1. Well, 36 minus 84, 36 minus 84 is going to give us negative 48. And we're talking about feet per second. Now, this is a negative velocity. So what does that mean? Well, it means it's going 48 feet per second in the negative direction. So in this case, since we're talking about dropping something, we're talking about up, down. So that means it's going down at a speed of 48 feet per second. Remember, speed is the absolute value of velocity. So we know it's going 48 feet per second. Without a direction, it's just speed. But when you throw that direction, either positive or negative, depending on the sign, that's going to give it the fact that it's a velocity, and it's telling it that it's going in the negative direction. So we're talking about negative 48 feet per second. So that's our first one. Our second one here, same rule. We're going to use S of T2 minus S of T1 over T2 minus T1. So we've got negative 16 times 1.5 squared plus 100 minus, once again, we know S sub 1 is just 84, so minus 84 over 0.5. Now, before we do this, let's ask ourselves the question, should our average velocity be higher or lower in terms of the speed when we're talking about a smaller interval? So at time t equals 1 to 1.5, do I have an average that's higher or lower than from 1 to 2? So I'm going to let you think about that. Think about it as a thought experiment. And we're going to figure it out in just a second, but kind of use your brain to think about that for a second. Write down whether you think it's going to be bigger or smaller. And then let's do it. So negative 16 times 1.5 squared is negative 36 plus 100 is 64 minus 84 is negative 20 over 0.5. Negative 20 over 0.5 is just negative 40. So negative 40 feet per second. All right, so that's a little less, right? So we went from negative 48 to negative 40. Why is that? Well, think about it. If you're dropping a ball, it's gaining speed as it falls, right? So at time t equals 1, its speed is not as fast as it is at 1.5, but it's even faster at 2. So if we average these, it has to be smaller than the average of the whole thing because it's actually going faster in this region. So that's going to bump its average up a little bit. So let's look about from 1 to 1.1. So once again, we're going to plug in this value, negative 16, 1.1 squared plus 100 minus S of 1, which was just 84, over 0.1. So negative 16 times 1.1 squared plus 100 is 80.64 minus 84 over 0.1. So you've got negative 3.36 divided by 0.1, which is negative 33.6 feet per second, which makes sense because we know this was 40. We've got a smaller interval, so now we're talking about just this interval here. So these are all smaller speeds than down here, so it's got to be a little bit less. So this kind of gives you an idea of what to expect out of these problems and kind of what direction you should be going in terms of your answer, right? If you did one and then the next one you got a smaller interval, but then you got like a massively higher speed, you know you've done something wrong. All right, so in general, if s is the position function for an object moving in a straight line, then the velocity of the object at time t is just given by the first derivative of the position function. So velocity is the derivative of the position function. Velocity can be negative, it can be zero, it can be positive, it doesn't matter, right? But it can be, and it's going to be the first derivative of the position function. Now, the speed of an object is just the absolute value of its velocity, so remember that speed is not going to be negative. Velocity can be negative. Now, the position of a free-falling object, if we neglect air resistance, so we're talking about falling in a vacuum, under the influence of some gravity, can be represented by the equation -1/2 gt squared plus v naught t plus s naught. Now, in this case, g is the acceleration due to gravity. V naught is the initial velocity of the object, and s naught is the initial position of the object. Now on Earth, we give g a value of 32 feet per second, or 9.8 meters per second, depending on which units we're talking about. So if your problem has feet in it, you're going to use 32 feet per second. If it's got meters, you're going to want to use 9.8 meters per second. Now, some of you may be like, why do you keep saying per second? Why are you saying it twice? Because what this means is 32 feet per second squared. Okay, so and that's an acceleration. So acceleration is always in distance by time squared. We'll see why later on in the world. But this is an important equation. Some of you that have taken physics might recognize this as a derivation of one of the kinematic equations that you use for basic physics. So we can actually do a few problems now. Say we've got time t equals 0. A diver jumps from a platform diving board that's 32 feet above the water. So we've got a position of 32 feet in the positive direction. Now, the initial velocity of the diver is 16 feet per second. So that means he's going up at 16 feet per second because it's a positive velocity, right? We know that velocity has direction. And we can see that he's going to go up, he's going to come down and do this. So we have like a parabola, right? This is a parabolic function. Now, we want to determine when does the diver hit the water. Well, if he hits the water, what's his position? That's at ground level, that's 0 feet, right? So basically we're saying, at what time does s equal 0? So we're looking at our function, s of t equals -1/2, and since we're in feet, we're going to talk about times 32 feet per second, t squared, and then plus 16 feet per second times t, and then plus the initial position, which was 32. So we're asking, when does that equal 0? So when does that equal to 0? Well, we know this is going to give us -16 t squared plus 16t plus 32 equals 0. So I'm going to factor out a -16. It's going to leave me with t squared minus t minus 2 equals 0. So to solve this, I need to factor. I get -16 times t minus 2 times t plus 1 equals 0. -16 can never be 0, but t minus 2 can give us t equals 2, and t plus 1 gives us t equals -1. Now, t equals -1 doesn't do us any good, right? Because I can't talk about what happened before I jumped. But if you want to talk about what does it mean, well, think about this. This is a parabola, right? So this means that t equals 0 here. We're going to go up, go down, we get to t equals 2. But if we talk about this side, this would be like negative time. So t could be equal to -1 if we went this way. So that's like what happened before. So you're basically just you're drawing in the portion of the parabola that you're not actually physically using. So since the t equals -1 doesn't matter, we get t equals 2 seconds. Okay, so when does he hit it? at 2 seconds. Let's always make sure and put our units on here. So the second part of this question is, what is the diver's velocity at impact? Well, I know that S of t equals negative 1/2 of 32, so negative 16t squared plus 16t plus 32, right? I know that impact happened at t equals 2. Well, how do I find velocity? Well, I know that velocity is just the first derivative of position. So 2 times negative 16 equals negative 32t decreased by 1, and then plus 16 because you just take the number in front of t. So we plug in t equals 2, we get negative 32 times 2 plus 16. So that's negative 64 plus 16, negative, gives us negative 48. So we got equals negative 48, and we're talking about velocity, and we're talking about feet, and we're talking about second, so 48 feet per second. So if you have any questions at all about any of this stuff, velocity, position function, any of the rate of change stuff, please just shoot me a reminder or ask a question in class.